Hello, Mr. Kabat.
Hello, Dennis.
Just a short introduction. Um, Tom Kabat is a Cal Poly SLO, San Luis trained engineer, energy engineer, environmental and mechanical, and with more than 30 years of gas and electric utility planning experience focused on efficiency and renewables. He's now at work preserving the climate. Lately, he focused on developing tools, analysis, guides, products, and policy to assist with electrifying everything in buildings, including cars, as long as the cars are in buildings, I suppose. But he'll talk today about getting the most out of your home electricity panel. And I'm legally obligated to mention that Tom is famous as the inventor of the carbon burger. And you can ask him about that in the Q&A if you're not familiar with the carbon burger. But let's talk about panels.
All right. Well, Dennis, thanks for the nice introduction. It's a pleasure to be here with Sustainapalooza again and to get talking about two things. Really, I want to talk about the electric panel, but also about a home electrification plan. And the idea of the plan is it's the way to end up help preserving the panel. And so I do have a slide presentation. Maybe I could cue that up and take people through that. Or do you have a different idea?
Oh, please share the screen.
All right, let's see if I can get the right thing going here. All right, how do you get to see a cover slide on home electrification plans?
I was muted, sorry, with a very nice background.
Oh, all right. Okay, so when doing these home electrifications, helping people convert their house from using fossil fuels that are kind of dangerous and smelly, as Sean mentioned earlier, and Sean and I do a lot of work together developing the guides for home electrification and commercial buildings. Actually, right now is when we're working on how to retrofit those. But as we do that work, we come up with tools and methods for people to follow to try to make life easy. And what we've been noticing is that when you've got this regular, very standard 100 amp electrical panel on your house, it can deliver 24 kilowatts of power, and that's like 32 horsepower. It's a whole lot of energy coming per second into your home. So it can achieve quite a bit, and we don't really have to upsize them as often as the upsizers keep telling us. And it's kind of like when you ask your electrician about it, you're asking your barber if he thinks you need a haircut. And you know what? For $5,000, he thinks you do need a haircut. So, but what I decided to look at carefully a couple of years ago was how can we electrify without upsizing so many panels? And the reason to do it is to save the money and the time, because sometimes these upsizing projects involve PG&E and getting permission or having studies done and then getting permission to upsize the connection to the grid. And PG&E may have to upsize some of its pole top transformers and other things. So if you can kind of stay on your panel, you don't have to involve PG&E. They still will have a task of trying to keep up with the neighborhood as time goes on, but it'll be a bit easier if everybody were watt dieting and staying on their existing panels. So, what we're noticing is we're starting to do the right things in California, but we have to do them so much faster than we're doing them. And the electricity is getting cleaner and the gas is just as dirty as it's ever been. So we have to electrify everything on the ground, including the cars. And so that means we really have to figure out how do we electrify homes and leave space still for car charging. So to do it affordably, it kind of makes sense to have an electrification plan so that one project, you may have like 5 projects, the space heat, the water heat, the cooking, the drying, and car charging. If you did one of them really big and opulent, it might paint you into a corner where you can't achieve the others. And we see that a lot in a nearby community where they have a high uptake of EVs, and the EV electrician salesman keeps trying to convince everyone to put in very large 50 amp circuit chargers. that deliver 250 miles a night. And you don't really need that many miles a night when you're only really driving 50 miles a day. So, it makes sense to take a look at your charging needs a little more holistically. So we can skip the utility issues. The three separate methods of this watt dieting or panel optimization. If you don't like the term dieting, really what we're doing is optimizing the use of your existing electric panel. The three methods are, A, is to select inherently more power efficient devices, the things that get their job done without using a whole lot of power at any one time. And then another method is to use controls that sequence or pause the operation of certain devices that can be paused while others use the power. And so things take turn. It's a little bit like air traffic control for the home. And then the third one might be adding some kind of controlled storage, but that's a little more complex. But you can definitely start with this efficient power device selection and then later add controls or storage. I really like trying to use this little graph to help explain things. The bottom axis, headed off to the right, is 0 to 12,000 watts on the panel. And so that's up to 12 kilowatts on the far right side. And then these kind of 5 categories are the basic end uses that we're trying to meet, like drying our clothes in the top one, and then cooking and hot water and heating and cooling us, and then EV charging in the bottom. So I show kind of an array of these different lengths of the bar representing how much panel capacity it takes up to do the different types of devices. And so earlier you heard Sean talking about his combined washer condensing dryer. He has one, I have one, Steve Schmidt has one. We've all kind of fallen in love with this device, and it puts no added load on the panel because it's using the same circuit the washing machine used. And then other ways you can go is you could add a heat pump dryer to your washer, or do a condensing dryer, or a hybrid. It's kind of half heat pump, half resistance, or a full-on resistance dryer. And so you can see a range of panel space taken up by the different types of dryers. Here's a similar thing done for cooking. And for cooking, the big savings is when you use a slide-in device called a range, which has a cooktop on top and an oven built in underneath, and they do some power sharing between the two. If you get separate wall ovens, like my house, we unfortunately 20 years ago put in double electric wall ovens, so we're a little further out there. But in the hot water choices, Sean was mentioning, we can get these 15 amp versions of the heat pump water heater, or the standard 30 amp version. And starting later in July, one of the first companies, Rheem, is coming out with their plug-in 120 volt retrofit ready water heater, part of an effort that Sean and I have been on for a couple of years to have manufacturers start rolling out those products and develop a standard for those. So that'll be a nice do-it-yourself project too, a little easier to plug in your own water heater. And then for space heating and cooling, we recommend people use right-sized equipment. So typically only up to about 3 tons of, and that's a ton is 12,000 BTUs per hour. It's an indication of the heating and cooling power of the machine. And using the very high performance, so HSPF 11 or higher versus the standard 8.5, and then avoiding these things called electric resistant strip heaters that are built into old heat pumps in the old days, and they live on in the mythology of people who don't want to install heat pumps. but you don't need them in California, in the Bay Area. You don't need resistant strip heaters. You just need a nice inverter driven heat pump, and an efficient one, and it's going to keep you warm and cool. And then for EV charging, you can, I hear about half of all EV owners do their charging just off a regular plug-in 120 volt plug. They just plug it in the garage, because the car came with a charger in its trunk, and they just plug that cord in. And then here's just more models of, if you want to go up to 240 volt charging on say a 10 amp circuit, or here I'll pick this 20 amp circuit right in the middle, it would deliver 108 miles in 8 hours each night. That's 39,000 miles a year. and only need a 20 amp circuit to do so. So those are the kinds of things I end up recommending in doing these electrification plans, so that people don't have one project take up all the space and then they can't do the other projects. So when I talk to utilities about it, I'm trying to get them to restructure their programs from offering incentives on big old stuff to offering better incentives on small stuff, on ways to efficiently meet your needs so that we all can do it faster. Because if we just let the fast rich people run to the front of the line and clog up the whole utility system, how are the rest of us supposed to get there and electrify? Why don't we restructure to have efficient programs that leave space for everyone to do the electrification? And then, so here's just like a simple device replacement list. So for water heaters, get rid of your gas tank water heater and get a larger size tank. It's because a tank is a thermal battery, the tank of water. So go for the 65-gallon tank or the 80-gallon tank, whatever fits in your garage or your space, but go for the lower power version, the 15 amp version. It's a special order thing, or the 120 volts are coming out, so go for one of those lower power ones. Get rid of that big old clunky gas rocket in the garage that's doing your heating, because it just kind of overcooks you and then that turns off and coasts and you undercool. And so get one of these 3-ton inverter driven heat pumps that are high efficiency, and it kind of stabilizes its temperature of the house by delivering just the right amount of power. That's what's the beauty of that inverter driven component. And then you don't even need these central air conditioners anymore. One heat pump is cheaper than a furnace plus a central air conditioner. So then for cooktops, get rid of that 36-inch smelly gas cooktop. Like I had that 5-burner thing and put in a 36-inch 40-amp induction cooktop. And we don't miss the smell of gas, and we like having precise cooking. It's a lot neater than it used to be, and it's safer for us. Plus, during that heat wave, our kitchen didn't overheat last week or earlier this week. So the cooking is nice when you've got the induction, because the induction directs the heat right into the pan. That is where the heat is actually created, is inside the metal of the pan. And so it's not leaking out into the kitchen and overheating the cook. On the dryer, I go with Sean on this thing, and I really love my combined washer dryer machine, and it freed up $10,000 worth of space in the garage. So that's kind of nice too. Because if you look at our real estate prices and what is that, what is the cost of that space in the garage, or actually mine's upstairs because we have our upstairs laundry, it's nice to free up that space. Then on the last one, pick that right sized EV charger. Don't oversize, don't carry over this form of range anxiety that makes you think you need an extra big charger to start with. You could choose to put in an extra stout wire. You could put the wire in, say a 6-gauge wire that could handle the much bigger charger in the future. But don't put, don't set the thing up to draw all that power. A lot of these chargers are adjustable. They have dip switches inside them. And so when you tell the installer to install it, you can say, set it for 30 amps or set it for 20 amps. And they'll set it and it'll flow that amount. So here's just a couple of pictures representing what was on that kind of replacement list, is just switching from, standard 50-gallon gas water heaters up to, say, in this case, we were recommending in this plan an 80-gallon 15-amp heat pump water heater. And the reason we recommend these larger storage tanks is twofold. One is it can deliver more hot water during morning rush hour when you've got all those showers happening and keep you hot, because I don't care how long it takes to recharge my water heater. I care that I get all the hot water I want when I want it. And having a big storage is what delivers that. And then I let it take its time and recharge across the middle of the sunny day and help get rid of that excess solar energy that floods California's grid. So in a way, I'm using my my heat pump water heater to help balance the grid. The next thing we help people do is this house had started with a gas furnace in the closet and a 2 or 3 ton air conditioner outside. And so we switch over to using a 3-ton mini split that's got a smaller form factor outside it. So it goes in the same place here, it just sticks out half as far. And then it's got this air handler with with refrigerant coils in it that replaces right into that same spot where this furnace had been. So it's just a simple, we call it box swapping, and you'll see that in the Redwood Energy retrofit guides also that Sean was mentioning. We'll put a link in the chat. And then, here's one of those high-end AGA. He was recommending for the real high-end cooks, those AGA induction cooktops. And this cooktop, this whole range is cheaper than that big gas one. And then on clothes drying, I think my partner in this project, she really likes the hybrid dryers, which have a heat pump and a resistor. So there was enough space to fit one of those on their panel. And then in that project, we actually did some of that type B watt dieting I talked about, which is to use circuit sharers. Like Sean held up the Simple Switch brand version, and it's a circuit. Simple Switch brand now makes pausers and sharers, different types. And so we're actually proposing that they use this Simple Switch brand pauser in that project. But there's another thing coming out of Silicon Valley, the span.io panel, which is a whole electric panel that has prioritized in a sequence all the loads it would shed if it had to shed a load. And so you could put your EV charger on the lowest priority. And then if all the other loads in your house got up to where the panel was needing 80% of its juice to meet everything else, it would pause the car charger. If it went even higher, it could pause the pool pump. And then later when dinner's done cooking and those loads are down, it just brings back the pool pump, brings back the charger. So it happens in an automatic sequence in that panel. But these devices here in the middle, the pausers do that for one device. And so it's one way to go. Then with EV charging, we're recommending people get these adjustable chargers that have those internal dip switches. And the budget option is to put in just a NEMA, say 615 circuit, which is a 12 amp, 240 volt circuit that's still going to give you, say, 25,000 miles a year. We've done some studies of how much of people's panel do they use. We take a look at their electric load data over the course of the year, find the highest hour use that they used in the whole year, and divide by the panel capability. But the highest they used in the whole year for the highest hour, the peak hour, was often, was always under 40%. And so they've got a lot of electric panel space left on their panel according to their metered usage, which is every 15 minutes at my house and a bunch of other houses, and every hour at the other houses in PG&E territory. And then here's Josie's and my houses. Mine's all electric, except my EVs are both bicycles, and hers is all electric except for her water heater. She's been holding out. Next month she can get that 120 volt water heater we've all been waiting for. But notice with our all electric houses, we're also still down here. And these are the clients before, and here's Josie and myself afterwards with our houses. So the big question for people is like, when you're going to do this electrification and you start talking to the pros and thinking about it yourself, it's who will be these good stewards of the panel? Who will really set out and allocate the space on the panel so you can go as far as you possibly can? And one of the ways I look at it is, why don't we meet all the stationary uses as efficiently as possible, and then find out how much leftover car charging there is to overcharge the car battery faster, or let me skip more nights of charging or something like that, whatever it is for car charging. So anyway, electrification plans are kind of like a map to fit together the little Tetris game that goes on when you're doing a whole home electrification. So what's in some kind of electrification plan? It can be as simple as a list of devices by sizes and type of device. And so, repeating some of this stuff, it's like a 65 or 80 gallon, 15 amp heat pump water heater. And to get a 15 amp version, often it's a special order. So ordered ahead of time. Don't wait for your water heater to burn out. You're not doing the environment any favors by running your gas water heater another year. There is no resource value in the tank of your gas water heater. It will be recycled either way. And so you're not going to help the world by stretching out its life longer. So make a plan to replace it. And then for the heat pump space heating, we're recommending typically in our climate 2 to 3 ton, inverter driven, high efficiency, with these heating season performance factors bigger than 10.0. So they make 11, 11 and a half. So anyway, something bigger than 10 and no resistance backup in the unit. And none of these toaster coils in that distribution box that they might need in some other climate like Wisconsin. So on the dryer, I've been pitching the combination machine, but Josie likes the hybrid machine, which is just a clothes dryer. So she has to move her clothes into it, just like normal people. And then it uses either resistance or heat pump or both to dry it. Imagine if you had a dishwasher and a separate machine next to it called a dish dryer, and you run your dishwasher, and then you've got whose turn is it to move all the dishes to the dish dryer? And you move it over. And once you've done with the combined machine, like Sean and I, you kind of don't look back at wanting 2 machines. And then cooking, go with these combined slide-in induction ranges. If ever you remodel, I recommend that. Otherwise, if you go with wall ovens, you're just adding more circuits. But if you've got space and want to do that, you could. And then EV charging, I recommend getting over range anxiety and just recognizing that these larger circuits charge the car for many more miles than I ever want to drive. I do not want to go that far. I don't have time to drive around the Bay Area, those many thousands of miles. So what might you include in an electrification plan? You could have a simple drawing of your site plan with your house on it and showing where you would maybe put the outdoor unit of a heat pump. And so it's going to try to grab heat in the winter out of the air in your side yard. And in the summer, it's going to try to dump heat there. So it's where to put this device that'll make some noise. It'll be, say, 40 to 50 decibels, which is a pretty quiet machine, a lot quieter, say, than a pool pump, and quieter than most of today's air conditioners. The thing about a heat pump is they're designing these inverter-driven heat pumps with a long operating time in mind. So they're designing them to be quiet and to run steady and not be snapping on and off. So they run steady, modulating slowly up and down as needed to meet the house needs. And they just keep going. And so they're kind of a good neighbor machine compared to our air conditioner compressors that a lot of people, or not a lot, but some people have now. You can also make on that drawing some one-line diagrams just showing where the route would be for the electric circuit from your sub panel or your main panel headed out to each of these devices. And an optional diagram, you could show the panel once it's all electrified. I'll show you an example of that. And then any specifications for sizing the heat pump water heater, dryer type, and the EV charger. And any special controls if you wanted. See, I showed you that car charger, the circuit pauser. But here's just a diagram that a few of us put together. There's some of these in Sean's retrofit electrification guides, just showing example homes. Here's how the circuits could be arranged. And these green circuits were all the ones we messed around in to do the full electrification. And it all fit there, under 100 amps. And so they don't have to upsize their panel, and they still had room to put in a 5.8 kilowatt solar system feeding into that. And, so life was good. They met a lot of needs. So maybe here's an idea of a generic plan. And it's so order the largest tank water heater you can fit that's 15 amps and just do it now. Order it now, quit waiting. And because with the supply chain shortages, it takes a while to get things. It may be 6 weeks or 3 months to get one of these 15 amp water heaters. So that, or if you want the 120 volt, order that as soon as it comes out. Early July is when it's going to become available to order. And get in line to get delivery of those things. And then decide on how you're going to do your drying. And then put in the circuits for the water heater and the cooking and the EV. And then I'd say first, get to the heat pump water heater first. Oh, why am I so urgent about the water heater? I asked my wife, how long can we go after each of these devices fail? Water heater, furnace, cooktop, dryer, car charger. For car charger, she said a couple of years, it'd be no problem. We would just be plugging into a 110 volt outlet we've got outside in our driveway anyway. For the it was funny, for the furnace, it was 2 weeks max, even though we had gone 2 years. So she didn't even remember that I disabled the furnace a couple years before I put in the heat pump. But we just got by for a while with a portable heat pump that sat in the window. It was a two-way air conditioner, and with resistance heaters, and it was fine. Anyway, so she says a couple weeks for the furnace and 2 weeks for the cooktop too, because you have so many cooking alternatives like countertop devices and restaurants and takeout. There's just a lot of different ways to meet your meal needs. And then, but the hot water, it had to be 48 hours. So that is the real short fuse at my house. And knowing, how I can get graded on these things, I knew, okay, that's the important one that people need to be able to take care of quickly. Oh, and the dryer, pizza cake, you could always do a clothesline. So that's why it had another, I think she gave it a week on that dryer. So anyway, and I have a backup slide museum. Okay, so anyway, I'm going to turn off the sharing, and we can have a normal conversation, just see what people are interested in.
Sean, excuse me 1 second here. I'll get back. And thank you very much, Tom. I made a few different notes to check things out. But this has definitely been a master class in value engineering around the home. And I was just trying to track down the Redwood Energy documents and stuff on their website, but wasn't able to find some of the specific things.
Yeah, I'll put it in the chat. I can find it.
So we do have a couple questions. Actually, a first one about pre-ordering 120 volt heat pump water heater. I guess you mentioned Ream is the first. I know they have a relationship with Home Depot, but I guess if they're targeting, coming out say in July or something, there's going to be supply chain issues.
Right. So I don't know. It's interesting when they announce a date at which you can start ordering something. So then that tells me, and I think it was something like July 7th. So about that date, they're going to put stuff up somewhere, somehow, where you can order. So maybe it'll be online, but I don't know how to tell you more because I haven't ferreted out how they'll be telling us.
Yeah. So basically, I think it would be an issue of, it'll start in July and then continue through the summer into the fall. And then, probably with some passage of time, they'll be more available. Mm-hmm. But certainly, you mentioned the DIY aspect of that. I mean, you could start thinking that that would have some usage when it's that kind of plug-in.
Yep.
So there's some other questions in Q&A from Lisa Kirby. Hello, Lisa. If the exiting 100 amp panel is old and outdated, I mentioned a Federal Pacific, is it worthwhile to upgrade to 200 amp as part of replacing the panel?
It could be, for the individual. It could be. It depends on what their service line connection is like. And so the lowest cost case might be they have overhead service from PG&E, and that the wire's already stout enough to handle a 200 amp panel according to PG&E. That could happen. And so then, there wouldn't be that much extra cost for that customer. the other end of the spectrum is a customer who's got underground service through, under the street to their house from PG&E and coming up, and there isn't service wire is the name of that wire from the utility to your meter. And if PG&E notices there isn't really room to upsize on that service wire, they'd have to put in a new one. That might be, say, $25,000 or $30,000 to move up from 100 amps to 200 at that underground house. So it really depends a lot on what your service connection is like, and whether it's overhead makes it a lot more affordable. And then the other thing is the time adventure you may get into with PG&E for how long it takes for them to check things out, do studies, put you in their queue to do work, to do upgrading in the neighborhood to make these things happen. So, I think in her example, it's a case where they're going to replace an old obsolete panel with another panel. And, so they should check it out in themselves to try to figure out for their case, do they want to upsize or not? Is it costly or cheap to upsize? Or if it's costly, stay at 100 amps and just follow the watt diet and live large on 24 kilowatts. In my opinion, it makes you a better neighbor anyway, but not everyone adorns their nest to make themselves the best neighbor possible.
So you mentioned the underground wires, and so there may be neighborhoods that have underground wires. So is that a thing that the underground, that say there's certain neighborhoods where there basically has 100 amp service because it's an underground wire?
No, so there you might have 100 amp service just because the era the houses were built in. It's not because the wires are underground.
No, but I mean the service wire, if it's coming, through kind of an underground. I'm just wondering about the infrastructure in terms of the service wires for underground connections versus overhead.
Well, what I look at is overhead is just easy for PG&E to access and upsize if they wanted to, if you needed it. Underground is hard for them to access and upsize, but that's the real difference. It's not that overhead lets you, that they naturally built things larger overhead and smaller underground. That's not the case that I know of.
Okay. Yeah, I just wondered how big a story is that in terms of people wanting, say, to do, if they were looking, if they had 100 amp service and the service wires.
So I think it's going to be a very, so Dennis, I think you're onto something here because it's going to be a very focused story in some neighborhood tracts that were built all together underground where everyone demanded underground. And so, and they're all locked in at 100 amps. And so what I'm pointing out is they're going to be fine. They just need to pay attention, through this panel optimization or what.
Right. Yeah. I mean, if
there's no
he's gonna tell them
deprivation.
It's thousands, tens of thousands to upgrade to 200 amp service wires. Then, I just wondered how prevalent that was. And
it just depends on the tracks and when they were built and what was in style and all that. So. Okay. I don't know. I don't really have a map
actually, that raised my antennae. By the way, thanks for the putting the post for the Redwood Energy retrofit guide.
Yeah, and I put a specific reference to page 3738. I like putting in that reference because that's just kind of showing, what would the do-it-yourself cost be? And in that example, it's something like $7,000 or $8,000 for a do-it-yourselfer to do all that electrification and without rebates or any of that. So and then the thing I did was I became a volunteer for sunwork.org, and Sunwork's a great nonprofit here in the Bay Area that trains volunteers to install solar and heat pump water heaters. Now we do that too, but you can volunteer for Sunwork and you learn how to install these circuits, and then you can do your own projects. So it's a great way to cut keep the cost down and free up the workforce to work on the people who don't have do-it-yourself skills or ambition. Because what we're seeing in electrifying everything is we have got so much work to do, and the current workforce is not sized for it. And so what's happening is, as all this demand for these projects is going up, because people become aware that electrification is the solution, they're asking more for it, and the electricians are going, well, I'm not going to expand my shop, and I'm getting too many requests for service, I'll just raise my rates. And so what we're just seeing is bids are getting higher and higher. And so
Yeah,
the way
there's
around it for more people is do it yourselfing and obey the invisible hand. It's telling you to learn a skill and install your own circuit.
well, you have another homework assignment then for the chat in terms of the links for
Oh,
Sunworks, and I mean if there's any special
yeah.
links that you want to point out, because that yeah they have a great model. There's certainly a problem developing now that the case has been made so well for all electric. Basically, the uh, are just having major problems. It's led to a lot of inflation in terms of bids for sure.
Yeah. So I do see a couple of questions over in the Q&A. I can give a quick answer
Yeah,
to.
so that go ahead.
Yeah, and so Matt's asking about interaction of smart thermostats and nests and things like that after circuits have been paused, and I don't know of any issues with them. But again, I don't do a lot of home automation. Um, and then, oh so most of what I've talked about here is about our gentle Bay Area climate, and the generic plan definitely works well here. In Phoenix, you want to pay a lot more attention to the cooling calculation. There are these things that we call manual J calculations, where you look at the areas and conductivities of all the surface of the house and the amount of sunshine coming in and all that to do the cooling sizing. And in Arizona, cooling sizing's a bigger deal. So my just generic example of go for 3-ton units doesn't hold well in Arizona. You need to do the calculation and see, is it 3 tons, 2.5, or 4, or 5. So it just depends on what's going on there. So I recommend, considering the simple plan, and if you want to get more nuanced, have the manual J calculations done, and you can look up how to do those online and calculate it yourself. It's a spreadsheet exercise.
So, Tom, I just want to restate the questions because most of the audience can't see the actual Q&A questions. So the last question you answered was, is the Watt Miser, would that be suitable for Phoenix? And so you've answered that. The
Well, yeah,
question.
actually, I want to restate it. It's the
Okay, great.
Watt dieting is definitely applicable to Phoenix. The question was, does my generic plan of buy
Yes.
a 3-ton heat pump apply to Phoenix? And my answer is no. Phoenix is very different, and it might be 3 tons is the right answer for that house, but do the manual J calculation, because they're a more sensitive climate and a cooling driven climate. Whereas here in the Bay Area, most of us here, we are a winter peak heating driven needs on our heat pump. That's what will determine the biggest size heat pump I need. And I actually do the analysis. I take a look at the PG&E data and just see what is the highest days gas usage in the winter, and then see what size heat pump do I need that can deliver all the same heat that delivered, but do it in 12 hours. And then that helps me size systems really quickly without a lot of calculation.
There was a question about a spreadsheet for the Watt diet,
Yeah, and we've
and
got
that
that on the Redwood Energy site. Let
yeah,
me see if I
yeah,
can. I'll
okay,
put a link in the chat. I just maybe
yeah,
after
okay. No, that's
the
great.
next
And
speaker.
anyway, thanks for this what I was calling a master class in all electric value engineering. A very nice presentation, and I know it's given me a lot of fun homework
Right.
to work on as well.
Well, thanks, Dennis. I really appreciate being invited here to talk with you and the gang. And as we work our way forward, and we can do this, but we just have to show a little gumption.
Gumption.
Hmm.
All
Right.
right,
Thank you.
that's a good. We had a phrase of the day, and now we have a word for the day. So very good.